Hello, and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Jody Saultz.
Thanks, William. Thanks for joining today's Tech to Tech. We're going to talk today about troubleshooting cleaning in an inline cleaner. A lot of things come up throughout the year and customers have issues with cleaning boards, so we're going to go through that real quick. First thing you want to do is really determine what the issue is. Is it a machine, is it material, or is it the method? So sometimes you have to often ask yourself, my inline's not cleaning anymore, so what's wrong with it? As a chemistry company, first thing we would ask is that you check concentration, and verify that it's within plus or minus 2%. So if you're running 13% or 15%, plus or minus 2%, just to verify that your concentration is right, it's very important. Some customers run a lot of production, and if they have manual way of putting chemistry inside their machine, sometimes that concentration number might be elevated or it might be too low and it can affect cleaning. So if it gets out of whack, just adjust concentration back to the set point, run some boards and see if they come out clean. Another thing that's really important is chemistry likes to run at a certain temperatures, and there's a chemistry spec out there for that. So ensuring that your temperature is correct in your cleaner is very important as well. So find out what those specs are, and then verify that you're running the right temperature. And in some cases, equipment needs to be recalibrated every year. So it's always good to check that internal or that external temperature with a TC probe as well, just so you know that the fluid that's in your machine is actually reading what's on your computer screen. Another thing you can check, did belt speed change? A lot of times production people speed up machines, or maybe during shutdown, something has changed. So verify that feet per minute. It's very easily done with a ruler or a tape measure. And then also verify that the belt speed is not, or the belt's not slipping or jerking. Over time, these stainless steel belts on these inline cleaners, they have a tendency to stretch, and they could be jerking. And, if they're slipping, just verify that your conveyor is running actual speed of your set point and that it's running smoothly throughout the whole machine. Boards are too close together. A lot of times production people, they want to put product in the machine and they want to run it as fast as they can. If you look at the picture on the right, one shows good, one shows bad. The problem with butting these up is sometimes you get different deflection from the spray nozzles when it hits the first board, and it can affect the cleaning on the second board when it enters the machine. So make sure that you have a gap between your product when you're running it inside the inline cleaner. And check for crooked and clogged nozzles. Crooked and clogged nozzles, a lot of times you want that spray to have a full pattern throughout the whole width of your conveyor system, that you get good even spray across the board. Clogged nozzles, a lot of times, for whatever reason, that debris from inside the wash tank gets through the filtration system and it gets into the spray manifolds. And a lot of times it'll clog up those nozzles or those coherent jets. So make sure that you check those, make sure they're spraying properly, and make sure that they're not clogged. You can do that by bumping the pump, having someone bump the pump, looking through the machine and verifying that all these are spraying correctly. Did the profile change? Has somebody changed the paste? If not, just verify that the paste hasn't changed. Sometimes engineers are running different paste test or trying to use a different paste, maybe upstream, and it may affect the cleaning outcome if the cleaning agent isn't the right cleaning agent for that specified paste. So just make sure that hasn't changed and check upstream. Check parameters, ensure that there's no changes have been made in flow rates, pressures. And another thing that's very important is making sure that the chem ISO and the rinse are running correctly. There's a profile for reflow and wave solder, but not so much for cleaners. So when you really don't have anybody to tell you to just put some set numbers in the machine. A lot of this is done by trial and error. So just ensure that everything is running the way it should be, flow rates. If you have maintenance timers on those machines, make sure they're set up correctly so it can remind you when to do maintenance. and also the alarm settings. Make sure they're set within a spec that if they go out of spec, you readjust those or find out what the problems are. And last but not least, certainly check how old the bath is. A lot of customers run chemistry and they just run it. And eventually, chemistry eventually will get loaded up with flux. So it's very important to track this. When it's time to change that out, you really need to change that out so you can ensure that you're getting good cleanability out of your product. The best way to do this is to monitor the non-volatile residues that's inside that bath. You can take those samples periodically and see what those NVR numbers are. When you get those NVR numbers, if you'll back that number off a couple hours, you'll be able to track that NVR. So if let's just say, for instance, you're getting 100 hours out of your bath tank or 200 hours, and you start seeing some NVR problems at about the 200-hour mark, you want to back that off to about every 180 hours. I would start changing the bath just to ensure that you don't creep into that higher number and start having some issues with your bath. So end of life in a bath, a lot of customers out there, they really look at this bath as, oh, it's changed colors or there's some stuff floating around in the tank. It looks dirty. It doesn't look like it did when we first put that in the machine. That's typically not the end of life. Typically, some of the warning signs that come from your bath being spent are you're, of course, going to get decrease in the cleaning performance. You might see some foam, and then strange concentration readings or some erroneous readings when you're checking your chemistry concentration with your split test, or even if you have an automated system that's checking concentration for you. And then redisposition of soils or contaminations. When that bath gets loaded up and you're respraying that on your product, if you spray some of that onto your product, your water from your ChemISO and your rinse section are not going to clean that board off. And then there's a chance to drying some of those soils onto your product. And then when it comes out, it's more than likely going to fail. So make sure you really check, like I said earlier, about the NVR and track that and know what that number is so that you don't have these issues down the road. And really 4 things that you need to concentrate on. Time, belt speed, make sure that hasn't changed. You want to keep that impingement time where it was from the beginning. That dwell time in the machine is very important. An inline cleaner, running at 1 or 2 feet per minute, it doesn't spend a lot of time in the wash section itself. So it's very important to stick with those numbers and not speed those up just because you're trying to get product through the machine a lot quicker. Cleaning is important, and cleaning starts the wash, but it also ends in the rinse. And it's very important, like I said, that your rinse and your ChemISO are working properly so that you can get the proper time and impingement time needed from the rinse section. You still have to clean that chemistry out. So it's not only important to run and clean the flux, but you still have to be able to rinse that chemistry out of those components and out from underneath those components as well. So just make sure that you focus on that. Make sure that nothing is looking a little bit abnormal. And then energy, like I said, when you start having clogged nozzles or flow issues, you're really cheating the product from getting all the mechanical energy that the machine was designed to do in the first place. So double check those things. Solvency. Chemistry is designed to run good at certain concentration numbers. So make sure when that you're, like I said, within that plus or minus 2% of your concentration set point. And make sure that the chemistry that you're using is the best chemistry to help solubilize that flux. There's many different chemistries out there. Some of those chemistry formulations work better than others on different types of applications or different types of flux. So just make sure that you stick with the right chemistry and the right concentration. And then, of course, temperature. You want to make sure that the machine runs at the right temperature. Sometimes customers want to run lower temperature because they think it might save them a little bit of chemistry usage. That's not always the case. Sometimes when you run these lower temperatures, it may actually affect the cleanability of your product. So if you have any questions, make sure and get with your chemistry suppliers. They can give you a recommended chemistry spec for concentration, as well as a spec on the temperature as well for it to run the best. So in conclusion, like I said, figure out if it's the machine. If you're having machine issues, get with your machine manufacturer. Find out if it's the material, if it's chemistry related, contact those guys from your chemistry suppliers. They can help you determine, if your chemistry is working well or if the chemistry is actually spent and not working well. Or is it method? Has something changed in your recipe or your profile? But those are three of the main things you really want to focus on. Use the right chemistry that works best for solubilizing the residues or the dirt or grime, whatever you're trying to remove. And if you do get into a point, where you're really starting to change some things to see if you're cleaning your product, only change one thing at a time and go back and test to see if your board's clean. Because remember, if something has worked well for the last 6 months and then all of a sudden something went south, that means something in your process has changed somewhere. So it doesn't always mean that just because you have a good function, that maybe didn't have a negative impact somewhere else. So when you go to changing more than 1, 2, 3 things at a time, more than likely you could fix your main cleaning issue, but it also may have a adverse impact on something somewhere else in the process. So frequently asked questions on this topic. What's the most common reason boards come out not clean? In my opinion, it probably has something to do with maintenance or something has changed in the recipe. Maintenance meaning, in most cases, it's bath life. Customers need to really focus on that. You want to continue to clean product with a bath that is still able to solubilize your residues to be able to clean that product. So just make sure you really focus on that bath and make sure it gets changed out when need be. 'Cause a lot of times at the end of the day, when we talk through this with customers and you ask the questions, some of them will say, oh, I haven't changed my bath out in 6 months, or, so really focus on the NVR on your bath. Number 2, how can you tell if you have clogged nozzles or not? I say use the bump and run method. If you can get somebody to actually turn the machine off or on and off real quick for you, you can actually look in there, and as that machine starts up, because most of these machines have variable frequency drives on them now, or easy start motors. And most of the time you can see when they start up, and you can tell if you have a clogged nozzle or even a crooked nozzle if you have somebody just help you turn on and you're looking in there. So you can visually look to make sure that those are properly set and that they're properly spraying. And then how does bath life affect cleaning? Like I said earlier, when the bath gets spent or per se used up, you're basically, this flux is acidic. So when the longer you clean, the more acidic it tends to go. So when your bath gets spent, in most cases, it's going to overcome the cleanability of your chemistry. So it could start having, cleaning impacts. You could start foaming, which could start deadheading your pumps, and you could start running, maybe air or foam through those pumps as well. So you could have problems with that. So how does that really affect it? It's going to affect cleaning, and then it's also going to basically come to a point where you could have some compatibility issues as well when that bath starts going acidic. So thanks for joining today. Hope you enjoyed this week's Tech, and I'll turn it back over to you, William. Thank you.
Thanks, Jody. Thank you guys for tuning into this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@KYZEN.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.